Hi students, warm welcome to all of you to this concepts and snippets session. Today we are going to discuss chemical and ionic equilibrium. I hope you have studied a little bit of the introduction part in your 10th standard. There are many reactions when carried out in closed vessel occur in either direction, or such reactions never go to completion. The system contains both the reactants and product. A reaction that can occur in either direction is said to be a reversible process. Okay, for example, in a closed vessel, take ammonia gas. It is found after some time ammonia dissociate to give nitrogen and hydrogen, and the nitrogen and hydrogen combine to form ammonia. Okay, these processes are called reversible processes which can occur in either direction. Similarly, if you take hydrogen and iodine in a closed vessel, it is found hydrogen and iodine combine to form hydrogen iodide, and the hydrogen iodide dissociate back to give H2 and I2. That means such reactions never get completed because reactants are converted to product and the products react back to reactants, and the process occur at the same time with the same rate. A process in which the rate of forward reaction and the rate of backward reaction are equal, then the process is said to be at equilibrium. Okay, so let us start our reversible processes. You have irreversible processes also. For example, you burn wood, whether it is in a closed vessel or in an open vessel. Once wood is burnt, the products are carbon dioxide and water. Even if you keep it for 1,000 years, carbon dioxide and water never combine to give back wood. Such reactions are irreversible reactions. So, equilibrium comes into operation when the process is reversible. Okay, so processes, chemical and physical, okay, which can occur in either direction, are called reversible processes. Okay, then when a reversible reaction is done in a closed vessel, okay, the forward and backward reactions occur simultaneously. So, equilibrium is possible when the reaction is done in a closed vessel. Okay. Then, when the rate of, that is speed, when the rate of forward reaction is equal to the rate of backward reaction, when the rate of forward reaction is equal to the rate of backward reaction, the reversible reaction is said to attain equilibrium. Okay, so equilibrium is possible when a reversible reaction is carried out in a closed vessel. Equilibrium is attained when the rate of forward reaction is equal to rate of backward reaction. Hope it is clear. Now, once equilibrium is reached, all the measurable properties like temperature, pressure, composition, everything remains constant. But it does not mean the system is dead. Still, the reactions are going on in equal speed and in opposite direction. Okay. So, no visible change is observed at equilibrium, but both forward and backward reactions occur with the same rate. Okay. At equilibrium, all measurable properties at equilibrium, all measurable properties like temperature, pressure, and composition have a fixed value, a definite value. Okay, clear now? Very important thing, a catalyst has no effect on an equilibrium. It only helps to attain the equilibrium quickly. I repeat, a catalyst does not affect an equilibrium. It has no role on an equilibrium. It only helps to attain the equilibrium quickly. Clear? So, reversible processes are those processes which occur in either direction. It may be physical or chemical. For example, ice in equilibrium with water. It's a physical process. Nitrogen and hydrogen combining to form ammonia. It's a chemical process. The only thing is, it must be in a closed vessel. Reactions that can occur in either direction are called reversible processes. And remember, equilibrium is dynamic, not static. Okay. Finally, equilibrium state is dynamic in nature. Dynamic in nature. The only thing is, both forward and backward reactions occur at the same rate. Okay. Now, let us do a question. Before that, let me add one more point. What is that? Once equilibrium is attained, all the measurable properties I told you have fixed value. The last point is what? Equilibrium can be reached from either direction. You can start from ammonia, then you will get nitrogen and hydrogen. They are in equilibrium. Or you can start from nitrogen and hydrogen. Again, the equilibrium is attained. So, equilibrium state can be attained from either direction. Equilibrium state can be attained from either direction. Okay. Now, let us discuss a simple question. When a process is said to be in equilibrium, a process is said to be in equilibrium when the rate of forward reaction is equal to rate of backward reaction. Yes or no? Yes. So, the answer is a process is said to be in equilibrium when the rate of forward and the rate of backward reactions are equal. Okay. So, RF is equal to RB at equilibrium. I hope it is clear. So, we had discussed a very simple idea. We are going to discuss more and more detailed discussion on chemical and ionic equilibrium in the subsequent sessions. Okay. Thank you.